YouTube channel. Now this video will be continuation from alternate current and direct current. Over here we'll start off with how I'm going to detect or differentiate alternate current and direct current. To compare them, I put them in a table, left and right comparison. Now as for direct current, DC, in order to get direct current, you need a split ring. I mean, you split them, the two. For alternate current AC, slip ring. I mean, you slip through it. Okay, so this is how the configuration. Direct current, split ring, alternate current, slip ring. Okay, AC, you slip through it, AC. Alternate current, so you alternate current. Okay, so ring. So this is how it looks like, alternate current and direct current. So put in a word, for direct current, current flows in one direction only. Always positive or negative, depends how you connect them. Whereas for alternating current, current flow in one direction in the first half cycle and change to the opposite side during the second cycle. In some book, it is called sinusoidal alternate current, and steady direct current is what it says, meaning that you have always flat line, I mean the average number, or we call it an RMF, I mean root mean square value. Okay, so how do you get direct current? Now for this direct current, for let's say for battery, you get a flat line. You don't actually get this because the battery doesn't work as like what you get from previous video. I mean previous slides where you have alternating coil. Battery is electrochemical cell. The electricity you get from the chemical effect where the electron flows from one side to another, and then you get your positive and negative from the either terminal. Okay, battery. The same goes with direct cell. It's a chemical effect. It's an electrochemical cell. You get it from there. Likewise, the alternate current you get from a wall plug, 13M wall plug, house wall plug switch. Okay. Now here comes to the tricky part. Normally comes out in objective. How do you detect them? To differentiate them, detecting them, all you need is actually a light bulb and a capacitor. Capacitor and light bulb. Light bulb, the moment, this is the symbol for battery. Now capacitor is the symbol is two parallel line. So what happened? Initially you connect them. The moment you connect them, you light a while. Then once you connect for a while, later what happened? It no longer light on. So here, observation, light bulb does not light. Okay. Now, what happened to alternating current? This is a symbol, sinusoidal symbol, alternate current. Parallel, meaning is capacitor. Now, first half cycle is positive. Then it will induce another plate negative. The next half cycle, what happened? It changed its sign. Next half cycle, it become positive. This side become negative. So therefore, there is a flow of current. Alternating current, the light bulb, the light bulb or LED light bulb, or light bulb, it has to be light bulb lit. Okay, because you will learn sometimes later in the next chapter of capacitor. We have induction, mutual induction. It will induce when positive. When negative, you get positive. Positive, you get negative. Therefore, the current will flow. You just need to really understand the mechanism. It's actually a dielectric course, class. So for alternate current, capacitor, light bulb, light on. Another method to detect them would be alternate current, you connect to a coil speaker. Because what happened, one half cycle, positive, neutral cycle negative, what happened? The coil here create the induced current, and therefore you pull the metal in and out, so you get vibration, and the vibration compress and decompress the air, therefore you get a click sound, constant sound, click 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 sound, because the frequency is about 50 Hertz. You can actually hear it. So vibration. Whereas for coil speaker, the moment you connect it, you have maybe this diaphragm will go in or out, depends. Just one click. You don't have continuous click, so it's actually no vibration. You can see no vibration, because you learn about vibration. Vibration is what you get sound. Okay, because the first click you will attach it. I mean, we will pull it in. The electromagnet will pull it in, then that's no more vibration unless you disconnect it, then you release. So this observation is considered no vibration. So because of this observation, we use it to detect the difference between a direct current and alternating current for SPM syllabus. Yeah. So capacitor, light bulb, alternating current, light the bulb, coil speaker, your vibration for alternating current. That's all about it, to differentiate them. Then earlier I mentioned about the RMS value. What does it mean by that? It means root mean square okay, RMS. Now root mean square, it's actually the average value for your induced current. Okay, why is that so? How is it possible? Oh, my screen. Okay. How is it possible to have that when you have alternating current? What value do you take? Okay, so this is really tricky, or whether it's current or well, we took it current perhaps, or voltage, anytime, measure in second. What value do you read? Okay, so because of that, RMS comes in. What is RMS? RMS is actually a value of a steady current. So value of steady current that would produce the same heating effect in a given resistor if replace the alternating current AC. Okay, meaning if okay, if in the event that it were connected to a resistor, you get heating effect over the resistor. If it were to be a sinusoidal, what happened? Current zero maximum, zero maximum. Here you have less heating. How are you going to get the same heating effect in a given resistor if it were to be replaced by the alternate current, I mean the average value? what would this value be? Okay, in order to get it, your RMS value is actually your current, your maximum, by root 2. That's all. You doesn't need to really find out how to derive it. Okay, so this area here, okay, it's not in the syllabus unless you're going for higher education. I mean, you want to further study, then you need to know how to prove it. Otherwise, this would do. Okay, what is Imax? Imax is the maximum, this value. Okay, the same goes with your VRMS. That would be your V maximum by root 2. This is how you find out the RMS value. So in most of the appliance, where they normally mention about 240 watt in Malaysia, for example. Okay, this is actually the RMS value. Okay, this is not the maximum value. Okay, in order to find out the maximum value, that would be 240 times root 2, number without unit, watt. Okay, so in order to find out that, I think if you have a calculator with you, all you need to do is the value would be much greater than 240. That would be somewhere around 339 maximum. Okay, so the one we will read from the plug is 240 watt, 50 hertz. Is actually the S value. So in order to find out maximum, you need to times 1.12 or root 2. Okay, so this is what it meant. Actually, the average value, where you provide a steady current, produce the same heating effect in a given resistor. So this is the equation actually, or V is IR, so you use V max over root 2. I think this is all about that you need to know, that I feel, for AC-DC, alternate current, direct current. You get to learn more in depth on DC-AC. How do you convert them? How do you convert alternate current to direct current in the next chapter? And with that, if it's first time watching my video, kindly subscribe to my channel. I have much more video. And I really appreciate those thumbs up button. Share it with your friends as well if it's good, so that it benefit others. Best of all, it's free. With that, stay tuned to my next video.